today's LeetCode daily question. It's 989 add to array form of integers. So the array form of an integer num is an array representing its digit in left to right order. For example, num equal to 1321, the array form is 1, 3, 2, 1. Given num, an array form of an integer and an integer k, the array form of the integer num plus k must be returned. So what we can do is we can just add the elements and then give the output as array form, but the given input will be of length 10 raised to 4, and as we know that there does not exist a number which is of length 10 raised to 4, so we can't convert the array into an integer and just process it. So that's why this question can be solved in two different ways. The first way will be a non-space optimized way, where we are going to return the answer vector which we have created in the program, and the second way is going to be just doing this operation in place, which is going to be O of 3n for time complexity, that is O of n asymptotically, and then O of 1 space complexity. So first of all, let's try to write a code which is not space optimal and a normal form, which you can just tell to your interviewer. So let's start. So let's first of all create a vector called as answer, and keep an integer I which is equal to nums dot size. What we are going to do is, while I minus minus, or rather than minus minus I, greater than equal to 0 or k is greater than 0, we are just going to check if I is greater than or equal to 0, and if it is, then k plus equal to num of I, and then answer dot push back the k mod 10, and then k will be divided by equal to 10. We can reverse this, reverse of answer dot size, answer dot begin, and then answer dot end, and then we can return the answer. Okay, so this code will work absolutely fine if we just think about it, the algorithm, and this will work for sure. But what we are doing here is we are using O of n space, and we are using O of n time. If you can just check the loop of the code, you can see that we are looping from nums dot size till I is equal to 0. That means we are looping through the whole array, and also if the k is not equal to 0, then also we are looping through it, and then we are reversing the array, which is O of n costing. So therefore what this solution is doing is just adding a number from the back of the array till the front and then reversing it. Basically it's what it is doing, right? So we don't have to do this. This code is just adding to the k the ith element, and then just getting the last digit of the k and adding it to the array so that it can work. But we don't want something like this. We want something which can show the process of addition without using the extra space, and interviewer might ask you to code a solution in another way rather than doing it this way. So you must know the solution which I am giving you right now. That solution is going to be very straightforward solution. So let's reset this code and see that solution. So we don't need extra space, so we can just return num first of all, like this. And what we need is the size of the array. So size of array will be nothing but int n equal to num dot size. We'll also require a carry to keep track of carry of the number, and we will require an integer I which will be equal to 0 for just pointing a number in num. What we are going to do at the beginning is we are going to reverse the num array. So it will be reverse num dot begin and num dot end. So as we have reversed the array, we can just loop over it and do our operation. But you may ask why we are reversing the array. So suppose the input given is only one element for num, and our k is 10 raised to 4. Then to add it accordingly, what we have to do is just append the carry that we are getting to the nums array if it's not sorted, or if it's not reversed rather, then we just have to add it to the beginning, and adding to the beginning of the vector is O of n operation, and we can't take that O of n cost and increase the cost of our algorithm to n square. Therefore we are reversing the array by using just O of n time, and then we can just append to the end of the array, so that the costing of adding to the end will become 1, and we can execute that particular thing in O of n time only. Therefore we reverse the array initially. After that, what we are going to do is we are just looping till I is not equal to n, or till I have a k. And what this is essentially going to do is check if I have an element in the array or I have k which is not equal to 0. So I'll take the digit will be equal to k mod 10, and I'll have a result which will be equal to, if I is less than n, then only I will be accessing the num of I, else I will be assigning it to 0. After that, I will be adding a digit to the result plus the carry if I have any, and I am sure that digit will be a digit which is at the last of the number, or it will be 0 if the k is 0. So I don't care about any conditional check up there. After that, I'll just make k divided by equal to 0, and here also I don't take conditional check, because anything divided by 10, which is any number which is less than 10 and is divided by 10, it would give 0. So k will always be 0 if it's 0. After that, I'll check if my I is less than n. If it's less than n, I'll make the nums of I equal to result mod by 10, and I've incremented I here so that I will move to the next index. If my I is not less than n, it's equal to n or greater than n, then I'll just num dot push back the result mod by 10, so that I can just add element in O of one time, and after that I will just make my carry equal to result divided by 10, so that I'll get whatever digit I have at a carry position. After doing this, I have to check if I have a carry. So if I have a carry, then I'll push it to the num, something like this, and then I'll just reverse it. I'll reverse the num dot begin till num dot end, and I'm returning the num at the end. So as you can see in the previous question or previous solution, we were using O of n space and O of n plus O of n, that is O of 2n time. But here, if we increase the O of n time more, then we can just solve this question in O of 3n, which is just n greater than the previous 2n, which is asymptotically n only, which is equal time asymptotically, but we are reducing on the space, and your interviewer might get happy with this solution. So I hope you enjoyed this solution. I'll see you in the next one. Don't forget to like the video, share it with your friends who are stuck up in this problem, and don't forget to subscribe this channel. Thank you very much.